Nest is what we call an open research and innovation platform for the construction industry. We operate this platform for our partners, Nest partners, from the academic community, the public hand, and the private industry. These partners form projects together with us. We build houses with them, and they have the chance to install, validate, and demonstrate their innovations. One of the major advantages we provide is we take out the risk of the game, because here, although it's a real environment, these innovations, these prototypes may fail, and this will not have negative consequences for our partners. We have different emphasis, major research points, one of which is energy. So for example, all these projects, these buildings within Nest are interlinked energy-wise with various circuits that allow to transfer thermal and electric energy and operate the whole thing as a little city, an energy district. Inside Nest, you will find what you could call the usual suspects of today's energy technology. We have a variety of solar systems, photovoltaic systems from various partners based on various base technologies. We have solar thermal collectors. We have two systems, geothermal probes that harvest thermal energy from the ground. We have a variety of transfer, conversion and storage technology.
Well, here actually there's a diagram of all of the energy equipment, and down the bottom we have the energy hub, and there you can probably see the temperature storage. And then each of the units above is shown here with what energy facilities they have. Some have some energy generation, some have some storage as well. And the energy hub will communicate with these units to share energy in an optimal way. Okay, this unit is a fitness center, you see, with all the usual equipment. And on the windows there are integrated photovoltaics for generating electricity for use in the unit. And if there's excess electricity, of course, that can be sent down to the energy hub and stored for later use by this unit or another one. There's another form of generation here, though, and that's the cardio equipment. So operating the treadmills generates additional electricity for the building. At the moment, I'm generating about 40 watts. And, well, an energy hub is a collection or a system which controls energy from producers to consumers. A typical consumer might be a building, but the building may also be a producer of energy. It may have solar panels, or it may have other renewable sources in it. And the energy hub collects these together and manages in the way to maximize the efficiency. Well, the reason for using Nest is it has a central energy backbone, and that acts like the energy hub in there. And every unit in Nest, there are multiple units, has its own energy controller, so it can act as though it's a building in a city or in an energy hub network. A lot of these units have additional facilities that we can exploit here. For example, the Solace unit, this is an EPFL unit. This one has also solar thermal heating, it has PV panels, but it consumes energy from the backbone as well. So it's a perfect example of a typical building with some renewable energy and some energy needs from the grids. Okay, let me show you where this connection's made. In this technical room, you can see where all of the energy sources from the backbone come into the unit, and there's a control system here which controls the unit, but when we do the energy hub work, it's also going to be responsible for negotiating with the backbone. And this plan is created or re-evaluated every 30 minutes to 60 minutes, so that as conditions change, then the system adapts to weather conditions, electricity prices, or changes in the operation of the buildings. The challenges are in being able to work out exactly what each building should tell the hub in a way that allows the hub to design the energy flows or work out the energy flows in the next couple of days. You usually would have a mixture of residential, commercial and industrial buildings involved, but it could be as small as a village or a university campus or a city quarter. So there are a variety of things, but the general way of distinguishing them is that they have a supply of energy, a means for storing energy, and also the means of converting energy from one form to the other. Well, see, by doing this, you can make advantage of certain buildings having been able to produce energy and use it in other buildings, so you can be more efficient. And because you can also store energy in the hub, so perhaps one building might have, in the next day, an excess of PV power available, and the hub can store it in a battery and then deliver it to another building a day or two later. Because you can do this, you can put more renewable energy mix into the system and you can use the energy more efficiently.